All right, so we're going to work a little bit more with objects, and we're going to do some more syntax stuff. All right, so this is our second object class, and it extends a first object. What is an extension? An extension is basically saying that our second object is a first object. It's a type of first object. Because it extends it, it has access to all of these methods. Okay, so what we'll do is we will create our not main method. We'll create our constructor, right? All right. So same thing, right? So you can either do this or you can do what's called a super method. So when you extend something, you can call a super method that can basically perform the same task. So in that case, we don't need int val because of the super method. We're automatically storing this value, my val, in this. So what the super does is it goes up one level. So say you have your second object extends first object. So your first object is basically a parent to your second object class file, okay? So in that case, when we say super, we're going up from the child to the parent. All right, so that's an easy explanation, right? So we're going from the child to the parent. All right, that's what super does. We're going from the child to the parent based on this. So super basically means that it is the exact same method. Or what you could do is you could say super dot, get, right? That would dot get val, right? That would give you the val, except you would remove this super dot get val. That would call that method. So here we're just going to do super my val because that's how you do it in a constructor. Okay. Now we're going to do public void, not void, public and get val, and we can easily make that. Let's say get val, and then int new val. All right. So let's change this up a little bit. It's a little bit different. Right, so we're storing our my val in this super class, in this super, right, in our super class being first object. And now we're going to store new val as, so if you have both of your variables named the same, then you have to say that new val, sorry, I did it the wrong way around, like this. So what this says is that this dot new val, this meaning this class file, right? So this is basically a static reference. We're saying this class file dot new val. So this class file, meaning that it's this one right here, is equal to new val. All right. So what we're also going to do is we're going to do something different than we did last time. Last time we just did int val. Now we're going to actually do private int new val. Now what does this mean? When we say private int new val, and we can only do this outside of a main method, all right? Because this is basically, creating an instance variable, right? What this does is we create a private instance variable. Our instance variable is now secure. It can only be accessed within this class file. It can't be accessed outside of this class file. If you don't include this, it automatically sets it to public int val. What that means is that you can actually change that, you can actually manipulate that variable outside of the class file. Sort of like how you can call these methods outside of the class file because they're public, right? So that's what that means. Now, if we say get val, we're going to super dot get val, okay? Now, we're going to also change this so that we're going to take in a, let's take in a, an integer value, int ID, okay? So the ID, all right, so let's make what's called a comment, right? So we'll say that ID 0 represents the normal val, and then ID 1 represents the new val. All right. So what we're going to do is we're going to use something called an if statement. So if basically checks a condition. So we learned about booleans. So what an if statement does is it just checks to see it. So basically it checks this. If boolean is true, my bad, hold up, is true, then it does this. Else, meaning that if this statement is false, if this statement ends up being false, then it moves on to this. And then you can include an if statement inside of this else statement. Or you don't even need to do that. You would do an else if, and then you would do an else. So all that else if, like that. All right, so that's what an if statement is. So our Boolean in this case is going to be if ID is equal. This is called an equality operator. Okay, what this does is it just checks to see. We've already gone over this, I believe, right? The equality operator just checks to see whether both sides are the same. All right, I'm pretty sure we've already gone over this. If ID is equal to or has the same value as 0, meaning that we're checking to see if ID has in fact been given the value of 0, then we're going to say that we're going to do super.getVal. All right. Now else, meaning else if ID is equal to 1, right? We're checking to see if the ID is 1. Then we're going to return. I forgot to include my return statement. Return super.getVal. Return new val. And then we're going to include our last else statement because we want to include all possibilities. So say it's anything other than 0 and 1, right? Then in that case, what we're going to do is we're going to return 0. Just return a default value. So that's 0 right there. Okay? So now that we've finished that, so let's add some comments. So we're going to say, well, we've already included the comments here. We don't need to include any more. So that's what that does. Let's open up our first class. All right. Now let's remove this code. Don't need it anymore. Now let's do a second object. Obj is equal to new second object. Boom. All right. So those are just warnings saying, that first it's never closed and then we never use this. All right. Don't worry about that. Those are just warnings. They're not errors. We have no compile errors. And of course we have no compile errors. So if we run this code, well, after I do, system out line obj dot get val, and then we'll do sc dot next int. Let's compile that as well. Boom. And then let's run that code. Okay, so all right, run first class. So first thing we're going to input is this right here. So that's going to be, if we go back to here and we look at the documentation, it says that's int myval. Okay, so that's going to be the first object value. All right, let's give it a value of 7. The next one is this one right here, and we know that that is the new value. All right, so let's say it's 9. Okay, so now we have 3 choices. We can either do 0, we can do 1, or we can do any other number. So let's do 0. Uh-oh. What happened here? Throw 4 next int. It doesn't know what to do. Oh, that's because I accidentally inputted an O instead of 0. My bad. Let's rerun this code. That's my fault. All right, so 7, 9, and 0. It returns 7. Now, if I run that again, and I do 7, 9, and 1, we get 9. And if I do that again, and I do 7, whoops, that's my bad. 7, 9, and 2, I get 0. Boom, you see that? That's how that code works. All right, so what you can do is for any primitive data type, you can also, for any primitive data type, you can use a switch. There's no point in using a switch for a Boolean because you can use a an if statement for that, right? There's literally no point. Like switch Boolean, right? Just use an if statement. There's literally no point in using a switch. So a switch is basically an if statement, except it only deals with primitive data types, while an if statement can deal with objects as well. So in this case, because we're using a primitive data type in an integer referred to as ID, then we're going to say switch ID. So this is the value that we're looking at. So this is the primitive data. This is the primitive data variable that we are looking at. And so when we say case, we're saying the case is that if this is in fact 0, right? And then we're going to perform the following code. We're going to return super.getVal. And then we're going to break. And I'll explain this in a second. Return new val, break, default, return 0, break. Okay, so what does all this mean? So this is the primitive data type, as I explained before. So a case is basically like if that ID has this value, if it is equal to 0, okay? So if this primitive data type ID, which we know is an int, right, is equal to 0, then it performs the following code. It returns super.getVal, and then it breaks. What this break does is it actually breaks out of the switch. It exits the switch. That's what break means. It breaks this line of code, it exits it, and moves on. Okay, so this actually exits out of the switch, and in that case, it goes to the end of the method, which has nothing left, and so the method ends. That way, what it does is, if we don't include that break, what happens is that it actually goes direct. It goes to the next case, case 1, right? It automatically checks that next case. Okay, so we just want to break here, just in case. All right. So now we're going to return new, and anyways, it would return that default, right? It always returns as default unless it's been broken. Okay. So default just means it's the default condition. Otherwise, if it follows one of these cases, it performs the code inside of that. Okay. We actually don't even need a break statement there. Okay. So let's compile that. Unreachable code. Uh-oh. All right, it's returning. So there's no point in adding a break, because as soon as you return, right. Okay, so you don't need to include that break if you're returning something, because when you return something, it automatically ends the method. The method ends. So because we're returning something here, we don't actually need to add a break. But if you don't have a return statement there, then you definitely need to add the break. All right, so now that we've done that, let's test the code and see if it still runs. So 7, 9, and 0, return 7. 7, 9, and 1 returns 9, and then 7, oops, my bad, 7, 9, and 2 returns 0. See, same thing. The only thing we've done is we changed the if statement to a switch case. Okay, so that's one thing. Now I'm going to teach you something called loops. And what we're going to do for loops is we're going to create a method called public void increment by 1. We're just going to call it increment 1, increment next. How's that? So increment next basically just increments it by by 1, or we're going to say int increase, and then int num. So that's the number of increments. Okay, so what we're going to do is we're going to do something called a for loop. So a for loop, actually before that, let's actually do something called a while loop. All right, so whoops, that's not supposed to be there. What we're going to do is we're going to set a counter equal to 0. Okay, so this counter is starting at 0. Now we're going to do what's called a while loop. So this while loop is going to check to see if this counter is less than this increment times this number. Okay, so this is just going to check. Oh wait, hold up. Less than num, which is the number of increments. Okay, so this is the number of increments, and this is the counter. The counter is just counting the number of increments. Now we're going to. So this is going to be for val. For new val, right? Okay, so this is our increment. So this is our increase, and then this is our counter. Okay, so what is this code doing? All right, so what this code is doing is we're setting up a counter variable, right? So this is a global variable. It can be used anywhere within this method, all right? It's technically local, so it's global in regards to this, this method, but it's local in regards to this entire class file. This is a global variable in returns to this class file, but it's a local variable in regards to every other class file. In regards to every other class file, right? In regards to the entire, say, library, which includes multiple class files, this would be a local variable because it can't be used otherwise. So this is a global variable in relationship in regards to this method, all right? And so then this is our loop. It's called a while loop because it uses while. So what this is checking is it's checking this condition. While counter is less than num. So while counter is less than num, what we're going to do is we're going to run this code until this is false. Once this returns false, then it exits the loop, okay? So what this does is it increments new val by this value inc each time this counter is increased by 1. Each time this counter is increased by 1, new val increases by inc. Okay? Until counter reaches that value num. So let's test that. Okay? So, in our first class, we're going to change this from this because that's boring. That's a boring method. Let's do an actual thing. Object.increment. So let's actually do the same thing, right? Let's keep that. What we're going to do, object.increment next, and then it's going to be sc.nextInt, sc.nextInt. Okay. And we're going to run that. Okay, so we're going to do 7 and 9, of course. And now we're going to increment next. All right, so increment next is I and C and the num. Okay, so we're going to increment it by 3 each time. We're going to do it twice. And now we want the value of new val, so we're going to do 1. 15. Okay, so how did we go from 7 to 15? I mean, not 7. How did we go from 9 to 15? Well, we went from 9 to 15 because we incremented it by a value of 3 2 times. What is 9 plus 6? 15. So we've done 3 times 2. So this is the value that we're checking. Our counter is less than. So counter starts at 0. So it's checking 0 is less than 2. Yes, it runs that code. Counter is increased by 1. Then it goes back to that condition. And it checks. Okay, 1 is less than 2. True. Now it runs that loop. Counter is increased by 1. 2 is less than 2. False. It exits the loop. And now we're just left with 15. Okay, so that is how that works. So if I do 7, 9, 15, and then 5, and then 1, we get 84. Now, how did I get 84? 75 plus 9. 15 times 5 is 75, right? So we've added 15 to 9 5 times. 15 times 5, 75. 9 plus 75, 84. So that's how a while loop works. Now, what we can also do is we can do something called a for loop, which is basically a condensed while loop. Now, a while loop can also be used. This is a multi-line comment, by the way. A while loop can be used for multiple purposes, while a for loop can only be used for incrementation. Okay, so for int I, okay, I is our counter here. Let's just keep everything the same. For int counter is equal to 0, counter is less than num, counter plus plus. New val plus equals 8. Boom. This is our new thing. All we've done is we've changed int counter from being a global variable to a local variable that can only be used inside of this for loop. So that's the first. So for loop has 3 parts. It has the counter, the initialization and declaration, the instantiation and declaration and instantiation of some sort of counter variable. Then it has a condition that must be met to end the loop, and then it has an incrementation at the end. And so this is literally just a while loop, but condensed into this right here, this one line of code. So let's compile. And now let's run, and let's see if we get the same thing. So 7, 9, 3, 2, 1, 15. 7, 9, 15, 5, and 1. 84. Boom, we get the exact same thing. See that? All right, so those are loops and if statements, switches, and extensions. So that's it for this video, and I'll see you in the next one.